In this lecture, we are going to understand how to calculate the total number of trailing zeros in a given factorial. Number of trailing zeros means number of zeros at the end. So we want to find out the number of zeros at the end of a factorial when it is solved. And from this topic, we will get our type 4 of questions in the chapter number system. So let us start our discussion. Getting a 0 at the end of x factorial depends on 5. No 5 means no 0. So if we want to calculate the total number of zeros at the end of x factorial, then we will be expanding the x factorial first. And if in the expansion of x factorial there is a 5, then we will get a 0 at the end. Similarly, if there are two 5s, then we will get two zeros at the end of the factorial. And if there are no 5 in the expansion, there will be no 0 at the end. For example, let's say x factorial is 3 factorial. 3 factorial is equal to 3 multiplied to 2 multiplied to 1. And this is equal to 6. So 3 factorial is equal to 6 and there is no 0 at the end of 3 factorial. And when you see the expansion, you will find there is no 5 in the expansion and hence there is no 0 at the end. And with this, we can conclude the number of zeros at the end of x factorial is equal to the number of 5s in the x factorial. And now we will solve few more examples to understand this better. Example 1 is 5 factorial. We know 5 factorial is equal to 5 multiplied to 4 multiplied to 3 multiplied to 2 multiplied to 1. And when you solve this, you will have 120 as the result. And you can clearly see that we have 1 0 at the end. There is one trailing 0 in the result of 5 factorial. And this 1 0 we are getting because we have 1 5 present in the expansion. Now the question is, why do we get 0 at the end whenever we have 5 in the expansion? And the answer is 5 when multiplied to an even number produces a number having 0 at the end. 5 here when multiplied to 2 will produce 10, and here you can see we have 0 at the end. So single 5 in the expansion gave us single 0 at the end. Now let's see the example number 2. We have 10 factorial and we know 10 factorial is equal to 10 multiplied to 9 multiplied to 8 multiplied to 7 multiplied to 6 multiplied to 5 multiplied to 4 multiplied to 3 multiplied to 2 and then multiplied to 1. And when you solve this, you will have 362 8800. So in this way, we are getting two zeros at the end of 10 factorial. And the reason is presence of two 5s in the expansion. Let us find out the two 5s in this expansion. The first 5 is clearly visible and the second 5 can be obtained from 10. 10 is equal to 5 multiplied to 2. So our second 5 is in this 10. So total 2 5s are there in the expansion and hence we have two zeros at the end. So I hope you now understand how we are getting zeros at the end of a factorial because of presence of 5s in the expansion. Now we can observe one issue in this method. For 10 factorial, we have this long expansion. What if we have bigger factorial? In that case, this method will become too prone to the errors. So instead of finding the number of zeros at the end following this method, we will use this formula. We don't have to worry about the derivation of this formula. We can directly use it to find the number of zeros at the end of x factorial. The zeros at the end of x factorial will be equal to x over 5 plus x over 5 squared plus x over 5 cubed and so on. And in this, we will be finding the integral sum. That means we are going to add the integer values from these divisions. Now let us solve one example problem to apply this formula. In example number 1, we need to find the number of zeros at the end of 5 factorial. We know at the end of 5 factorial we have one single zero. So let us check if this formula gives us the same answer. So the number of zeros at the end of 5 factorial is equal to 5 divided by 5 plus 5 divided by 5 squared plus so on. When you compare 5 factorial with x factorial, you will find here in place of x we will have 5, and then we will divide 5 by 5 raised to power 1 plus 5 divided by 5 raised to power 2 plus so on. I stopped at 5 divided by 5 squared because from this division we will get the integer part equal to 0, and similarly all the upcoming divisions will give the integer part equal to 0. Now let us solve this. 5 when divided by 5 will give us 1. 5 when divided by 25 will give us 0.2, and we will only note down the integer part. So in this way we are getting 1 as the number of 0 at the end of 5 factorial. And the same answer we got here as well. So from now on we are going to use this formula to find out the number of trailing zeros or the number of zeros at the end of a given factorial. Let us now move on to example number 2. Find the number of zeros at the end of 5 factorial raised to power 2 factorial. So here we have something different. We have 5 factorial and then the power of 5 factorial is 2 factorial. We will first see the general formula to solve this kind of questions. Let's say 5 factorial is x factorial and 2 factorial is y factorial. So x factorial raised to power y factorial, we want to find out the number of zeros at the end of this. The formula is number of zeros at the end of x factorial raised to power y factorial is equal to k multiplied to y factorial. We know y factorial, it will be here. What about k? K is the number of zeros at the end of x factorial. So we first need to find out the number of zeros at the end of x factorial using this formula, and this will be our k, and then we need to multiply y factorial with k. This will give us the answer. So let us now solve 5 factorial raised to power 2 factorial. To find out k, we first need to find out the number of zeros at the end of 5 factorial, which we have found here. It is equal to 1. So k will be equal to 1. And from the problem, y factorial is 2 factorial. And therefore, the number of zeros at the end of 5 factorial raised to power 2 factorial will be k multiplied to y factorial. K is 1 and y factorial is 2 factorial, which is 2 multiplied to 1. So at the end we are getting 2 as the answer, and this means 5 factorial raised to power 2 factorial will have 2 zeros at the end of it. So I hope the 2 example problems are clear to you, and now I will provide one homework problem. Try to find the total number of zeros at the end of 40 factorial. Use the formula I have given, and once you have your answer, post it in comment section. So this is